Okay, so what's happening now? We found a ISMRM abstract from long ago called parameter-free reconstruction with compressed sensing or something like this. And I thought we'd implement it. We did, and it didn't work. And then we've been looking into why, and it turns out the reason why is because the error in the sensitivity maps is much higher than the noise in the MRI system. So then we looked into trying to find some ways to estimate the error in those sensitivity maps, and we seem to have done that, and still things aren't working. I was wondering if PDHG wasn't like converging well, if it wasn't getting the right answer. So I ran it for 250,000 iterations last night, and it's getting a good answer, and I can show you that now. And so the question now is what to do, and that's what we're going to be discussing today. Okay. So here's saving every 50 or so with PDHG. That's the initial guess. Here's the first one, and here is the 1,000th one. We'll open them both. And you can see there's a significant difference there. The first one's actually better in some ways. It's worse in others, but I would say it's overall better. Here's the first one. Here's the, let's go to 5,000 or so. Here's the 5,000th one. And when I say one, I mean the image from the 5,000th iteration. And you see things haven't really changed from the 1,000th to the 5,000th iteration. Let's see if that's true. I saved images every 50. Yes, things aren't changing. Okay. So what to do? I then looked at the result of FISTA. So here's what what PDHG is spitting out. It's getting the violation, like it's satisfying the constraint. The violation here is down to times 10 to the negative 16 or so. And then the sparsity is 0.9. Okay. Well, if we look at just the sparsity component, that is this part, the psi of L1, the L1 norm of psi of x of both the FISTA and the PDHG outputs, you see that the sparsity with PDHG is 0.9 and the sparsity with FISTA is 1.5. So PDHG is doing what we asked it to do. It's giving us a more sparse result that satisfies the constraint. And so the issue is that I assumed when minimizing this, that for whatever value this is, FISTA would then optimize this as much as possible. That, of course, is not correct. Clearly. Because for that same value, for that same, constraining this, we can get a more sparse version of this. Okay, so then the question is, I still should be able to increase epsilon to get out a result as good as what FISTA gives me. And we tried this thing where we increased epsilon, and it didn't work out. But we were only running for 200 iterations there, and we can see that even after, let's go to 1 to 200. After 200 iterations, the results are significantly different. And if we compare 200 to 1,000, they're changed, they're different. So PDHG hadn't yet converged after 1,000 iterations. So all of those experiments where we changed epsilon to see if we could get anything good out, we just didn't run it for enough iterations of FISTA. So what to do? It's annoying that FISTA takes so long. And I can think of two ways that PDHG takes so long. I can think of two ways to improve PDHG. One is add preconditioning into PDHG, and the other is warm start PDHG. Now, warm starting is hard because it's easy to warm start the primal variable. We have a good answer for that. Warm starting the dual variable is the issue. So there's a way to do that, but it's not trivial, and that's where we're at. So we could add this in. That would speed up PDHG. What else can we do? I'll just leave those to-dos up there. We could add dynamic stopping criteria into PDHG. At this point, PDHG with line search is intense. Like, I have added so many things into this code way beyond what PDHG with line search requires. And most of this is debugging. Like, for example, all of this is debugging, right? These are just for the metrics that I'm outputting. But dynamic stopping criteria is a good idea. Then we'll know we'll have some confidence that, we've run for enough iterations. Great. And the thing is, there's no general dynamic stopping criteria that I'm interested in. Maybe relative error would work fine, but I want to be sure that this constraint is satisfied to a good degree. All right, so that's how we're going to start today. We're going to add in dynamic stopping criteria to make sure that PDHG is running for a reasonable number of iterations. And then we are going to, so first thing I'm going to do, by the way, is just delete this. All these images that I saved. After that, then we're going to start trying to change epsilon to see if we could get a better answer, just a better image. I just want to see a good image come out of PDHG, and I haven't seen that yet. Okay, so dynamic stopping criteria. We're going to set it to false. And we're going to set it up now as just using relative error. But eventually we might allow a function handle to come in, and then you could specify your own dynamic stopping criteria. Okay. If empty is neither equal nor not equal to false. Okay, so this is relative error. Or relative difference, not relative error. There's no error. Okay. Okay, and so now we've got a function handle that is DSC, and you either passed it in or I guess I did it already. Okay. All right. All right. So we're going to need a DSC threshold. Sure. Let's add this stuff in. Okay, so optional inputs DSC. Use dynamic characteristics DSC thresh. When DSC is less than DSC thresh, iteration stop. And then n is the maximum number of iterations that PDHG will perform. Default is 100. Should probably change that to 1,000, don't you think? Because PDHG is slow. Now I want to put I want to see the relative difference. The thing is, now this happens after we update X. Does that matter? We're calculating metrics on X. Does that matter? All right. PSC value is equal to if numL C is greater than 0. And DSC is not equal to false. And DSC value is equal to this. If DSC value is greater than DSC thresh, break. If numL, if verbose equals true, no. Display string is equal to display string DSC value num to string DSC value. If verbose equals true, and numL display string is greater than 0, then do that. And else display string. $241. Okay. DSC I think is set to false. Should we just set it to true by default? Because we have no idea what the threshold should be, but the relative difference you'd think would be less than 1 times 10 negative 6. That's going to change a lot of things. We're just going to set it to false. Right. Index in position 1 is invalid. Huh. See what happened. How did DSC get the value of DSC thresh? Can you tell me that? Can you tell me that? That's how. DSC is true. But if DSC is true, it's supposed to replace DSC with the function handle that is this should be true. Okay. Does DSC equal false? Not supported for operator type. Okay. If is a DSC, I want function handle. There we go. We're going to call it as a function handle. It needs to be a function handle. The DSC value is 0.94. What is it the next time around? 2. Whoa, that got it larger. 1. Now, are these things not presenting printing? Why not? Because print every. If that's true. That's not. Why isn't that true? Okay. Verbose is true. Print every is 50. It turns out if you tell it not to print stuff, it won't print stuff. Some people might think of that as a human error, but that is obviously a bug. All right. Here we go. Objective value sparsity violation. DSC value. Stop. Point starts out. It's okay. We got some values here. 0.94, 2.2, 1.0. And in short order, it's down to 0.01. Okay. And here is 250,000. Or a function handle that is the dynamic stopping criteria function. This function must accept x and last x as inputs and output a scalar value. All right, looks like we've added dynamic stopping criteria into into your code. Now, I can make that a little tiny bit faster. Because look, we've already got diff(x). This is diff(x). Yeah. How much is that difference costing? I could make it slightly faster, but how much is that difference costing? I wanted to change how often this prints. Whoa, okay. Let's make it at least 10. Clearly it's taking longer. We used to do this just for 200 iterations, so we're like nearly done at this point. But the constraint violation is really bad. So that wasn't enough iterations. The question is, what is this DSC value going to be at some reasonable iteration where things stop changing? Maybe 1 times 10 to the negative 6 is about right. I don't think we're saving. Oh, we are. So things have stopped changing, it seems. Okay, so while this runs, let's keep thinking. Let's check in PDHG with line search. What do you think? It's weird that when I increase the size of the font, the window goes outside of the screen. I think that was using junk.mat, right? I guess it was using junk.mat. Didn't recompile when I changed the code. No, it wasn't using junk.mat. Oh no. Oh no. Okay. So let's put here. So was it stuff.net? Let's see where that breaks. That was somewhere else. Stuff.net is the data. Oh no. Well, what was proxconj using? I think it was using junk.net. We got to remake stuff.net. Let's call it kdata.net. What do you think? Sample mask not found. Where is sample mask created? There. Why do I have sample mask if it's that fast? I don't know. Okay. Should I have a print every here? It really does feel like I should. Hmm. We're at 600, and the DSC value is only down to 0.001 or so. So I think like something like 1 times 10 to the -3 would be very conservative, like more than we need. maybe in 1 times 10 to negative 2 for the dynamic stopping criteria threshold. Yeah, 1 times 10 to the negative 3 would be fine. That's what it's going to be from now on. This has gotten much slower, right? I could just put this here. Is it the calculation of the relative error that's slow now? Why don't we call this y dot mat? Okay. Let's change that to times 10 to the negative 3. Let's change that to 100. Let's see what's slow. Dynamic stopping criteria slower. It's surprising that it is, if that's what's taking the time. Maybe I just don't remember how slow it is. No, it's taking no time. Calculating F takes a lot of time. Because we're taking the wavelet transform. That's why it so slow, because multi-coil taking the wavelet transform. Proximal operator of F, which takes like the wavelet transform's adjoint and at the wavelet transform. Okay. Okay. So now come in here. This doesn't have to be 250,000. That was excessive, right? So let's make this 10,000. And hopefully we'll end within 1,000. with the dynamic stopping criteria, which is outputting images as we speak. So let's say, for the sake of argument, that I can actually change artificially by hand this epsilon to make the result of solving this problem good. Then I had to set it by hand, which is no better than just setting lambda. And it's worse because lambda can be solved with Fista. Engineering goes by so quickly, like it's already been 40 minutes. Okay. Let's see what image is. That's not good, and that's not terrible, is it? Or is it? I'll bet you it is. I just don't remember. That's amazing. Okay, so that is terrible. Glad we had that talk. So the sparsity of Fista is higher than that of PDHG. There is the possibility that I just needed to run Fista for more iterations. Could that be the case? Let's run Fista for 200 iterations. I haven't even checked if other lambdas gave a better answer, right? I just chose lambda equals 1, and the result was amazing by magic. Okay, that looks good. I don't know if it's better or worse, but that looks great. Okay, so it wasn't that. This is so fast. So epsilon S maps is something like 7 times 10 to the negative 6. Three times 10 negative 6. Okay. 3d minus 6. Sparsity is too low. So that would seem to think, that would imply that we need a lower sparsity. So let's try 1 times 10 to the negative 4. A stronger constraint, I mean. Let's try 1 times 10 to the negative 4. This is going to take a long time because PDHG is slow. Like I say, there are ways to speed up PDHG. We could do warm starting or we could do preconditioning. What? PDHG finished almost immediately. because the dynamic stopping criteria was, why did it finish almost immediately? Yeah, okay. Because the dynamic stopping criteria was met. Sparsity's even lower? Is that lower than what it was? Hmm? Hmm. So it was 0.2. Let's start recording these numbers. Like what's... Yeah, okay, so sparsity here is 0.9. Okay, so I just didn't run for enough iterations. It's actually higher. Because the dynamic stopping criteria is too high, which means that we're going to have to set it to something tiny. This threshold's not universal. And instead, I guess we'll do 8. Instead what? Instead we'll 1.5, 1.1. Rely on the number of iterations, which I think should be 1,000. Okay. Wait, I didn't change anything, did I? Just the number of iterations. So now let's go to times 10 to the negative 4. So now, imposing the constraint stronger should make it harder for PDHG to come up with a sparse solution. Why did it do that? N, because I got rid of N. Let's keep it. Just make it 1,000. I could, of course, just make a dynamic stopping criteria that ensures that the violation is met well. Looks like we're about to satisfy the dynamic stopping criteria, so that was kind of nice, and the violation's met well. Now the sparsity is 0.2. It's way more sparse. But I satisfied the constraint stronger. Right? Epsilon S maps got smaller. Ay, ay, ay. is not what I expected, and it concerns me. Another way to do dynamic stopping criteria is to look at the primal problem and the dual problem and just make sure the gap between them is small. I gotta reduce how often I'm printing these things. All right, you guys remind me, the 0 people that are watching the stream, you guys remind me to change that to 10. If after, a large number of iterations, the duality gap, the so-called duality gap, is large, then maybe it's an infeasible problem, and maybe that's just what's just happened. I ran into an infeasible problem. The sparsity now is 0.7, although I have no idea. Is it just very particular? Oh, you guys didn't remind me. It's not printing out the sub-iterations now. Why is that? Oh, because we only print them out when printf is equal to 1. Sparsity is 1.3 now and going higher. Oh, I'm so silly. 1 times 10 negative 4 is a larger number. So silly. Can I blame it on sleep? Surely I could blame it on sleep, right? Look at that. That's starting to look pretty good. Sparsity is 1.4. Okay, I was confused. This trend makes sense. 1.6. That looks excellent. Okay. We're in a place where things are working. Those experiments we did before, we didn't run FISTA long enough. These two are pretty close in quality. What we're getting out now, what FISTA is giving us out. Sparsity here is 1.6. So we're like off. We're off. So where are we? We started out with SPIRiT regularization way back when, right? And then I was interested in making the thing parameter free. I saw that abstract on ISMRM, and I thought that would be a very decent way to do it. So when we're not taking advantage of the sensitivity maps, the results coming out bad, right? Oh, maybe we just need to run that for more iterations. Let's find out if that's the case. We're still saving stuff. Yep. Yeah. That is really neat. That's really neat. So my one idea that I have right now that has any merit at all. First, let's see if we just needed to run this for more iterations, but I think the answer is it's going to be bad, and we're going to need to incorporate the sensitivity maps. What is this solving? There's no sensitivity maps here. It's very possible that SPIRiT regularization solves this. Makes this good, but we still don't know what epsilon is. Oh, right, we do, because this is the noise variance. Okay, so SPIRiT regularization might be the answer. We're not outputting the, I don't know how well the metric is being satisfied here, the constraint. Would have been nice to have included that. Okay, but let's say, before we include SPIRiT regularization, including the sensitivity maps makes this better if we set epsilon arbitrarily correctly. Right? Solving this problem makes things better than solving the problem without this. So the question is going to be, what is this? Now that we're running PDHG for a large number of iterations. But If it still fails, I wonder if we need a weighted norm here. Weighted by the magnitude of the values of B. Then it'll preferentially choose the lower frequencies, and that's sort of not what we want, is it? Okay, forget I said that. It's 3 times 10 to the negative 6. And what we need it to be is 1 times 10 to the negative 7. Shoot. I want it somehow weighted by the magnitude values of S. I guess that implicitly happens. You see, the issue that I'm thinking about is like out in the outskirts of K-space, there's really no signal. So this is going to be 0 regardless of what image is. And yet we're dividing by, we're like taking the average. Okay. I really do want to weight it times the magnitude of B. Oh. Okay. Is there a weighted norm in here? Let's make one. Oh, I don't know that. Well, I don't know. Let's see. Okay. Okay, so the simple thing to do is I think this needs to be raised to the 1 over p. And why is that? Okay, so like the norm is the inner product of the square root of itself. The weighting is is equal to n transpose diag w in square root. Yeah, so if we were to put w in both here, in both components, we need to take the 1 over p. This is assuming that the norm is the result of an inner product. I don't think the L1 norm is, but I think this still works. So what does it do if it's not a Hilbert space? Guess I don't need that. Maybe that's the thing to do, in which case I never needed to write this code. Where's the, oh, 0.1? Code, okay. Point 3. Is that luck? So this problem is equivalent to oh, okay. So I've got to, I've got to distribute this out. So instead of B, well, it's everywhere. Okay. WB, WB, WB. Did I do it? Let's see what that does. Another thing is like, so we don't need this divide by NB anymore. Okay, so now I'm gonna stop messing everything up. This NB, divide by NB, was a way of like averaging, I guess, I think. Why is that there? Didn't need this, did we? Let's make that apply A and make that WB. Huh. So that's not 0.1. Oh. Is that right? What is this for image Vista? Oh, I need to load it. Seven times 10 negative 7 for image Vista. 6 times 10 to the negative 8. So about a factor of 10 off. I'm just going to see what it does. It crashes. Oh. Fly A in, up. Still crashes. No, it's loading data. What just happened? Oh, right. Okay. So where did it crash? Not enough input arguments, line 386. What are you talking about? Oh, no, what are you talking about? 388. Oh. Okay, WMFSB. Where is it? I guess I'm going to call this WMFS. That's square root. What? Okay. Why was it? Okay. I don't know what that waiting term was before. $511. Oh. I want the larger values of B to be weighted more, don't I? .006. If we look at that value for image Vista, you're joking. 0.0068 and 0.0068. There's no, is that real? Wow. Why did it crash? Incompatible output sizes. Okay, so now this, okay, so they're both column vectors and that works. Apply S, so this is going to be the size of an image. 256 by 256. Okay. These have to be real. Objective value is 0. That means the image is 0. Why did the image become 0? Why is dynamic stopping criteria not? How is that possible? Why did that become 0? Oh, yeah, okay. We want to weight it by this. WMFS B is equal to WMFS times B. Where does this get used? In apply A, okay. Okay. So It's like we're using the weighted variance instead of the variance. Sparsity of image PDHG is not nearly enough. Yeah. Is there a bug here? Apply A becomes the weighting times MFS. And then B becomes the weighting times B. Projecting onto a ball assumes a norm. But now what I want to do is project with a weighted norm. I don't think that's right. X norm is a scalar there. That might be right. It's crazy that MATLAB can't get the font size of this window correct. That's just insane. Violation still's up at 2. We're at iteration 600. We're going to have to increase the number of iterations. I don't think it's going to get anywhere close to having a good result by 1,000. And we've got a spammer on Twitch. I wonder how spammers feel about their lives. So the sparsity is only up at 0.6, but the constraint is violated quite a lot. So we're going to have to set, let's try for n equal to 10,000. Do spammers ever wonder if life would be better without them? Like, how do they justify their existence? They like take from people who don't want to give. I'm saying spammers, but I mean scammers. Spammers are bad too, but not as bad. Okay, so the violation's at 2.2. And we're going to be going till 10,000 iterations. And that is intense. I'd like to know the duality gap. That'd be fun to know. But I guess when your constraint is violated, the duality gap is infinity. We're at 1,000 iterations and our constraint violation is 1.8. Is this going to get to anything reasonable? Project onto a weighted norm, onto a ball specified by a weighted norm. Looks like I didn't get the projection right at all. Yeah, this is assuming it's like the weighted L2 norm. Project ball weighted L2, okay. Param lambda. Hmm. I'm going to have to spend some time understanding this. How do they get the optimal? The optimal Vx is a function of param lambda. How do they get the optimal? It's a zero of this. The objective function where it's zero is the optimal value, optimal param lambda. The objective function where it's zero is the optimal param lambda. So if you give it a lambda, can I like close this? This is neat. This guy makes code for each question on Stack Exchange. That's really nice. Wow, this is how are we doing over here? Still a bad violation. But of course, it looks like the okay. I think the projection's wrong, so that's what's happening here. project onto ball. So this is clearly wrong, right? You don't just scale, which makes sense because you'd want to change the values of x that matter more than those that matter less. So here's an answer marked correct that looks wrong. That seems to be wrong. This looks like code that works, but orthogonal projection onto the weighted L2 norm ball. So you want to minimize x subject to y, x minus y. What is y? Oh, y is your current, yeah, right. Y is your current location. You want to project onto a ball. You want to minimize the 1/2 the L2 norm of x minus y. This is not correct. You only want to do that if it's outside the ball, right? I guess they're projecting onto the surface, not the convex set defined by the sphere. Okay. Sparsity is 0.8. I'm going to take a break. I'm going to see about projecting onto a weighted norm. And I might see you guys later today, or maybe I won't. I don't know. We'll find out.